I'm sitting here with Professor Chomora Mikeka on the first day of the rollout of a TV White Spaces trial in Malawi.
Perfect.
Dr. Mikeka, can you tell us what white spaces are?
Well, thank you, Steve, for the opportunity. White spaces basically are blank spaces. It's the idle channels in any radio band. In this case, in Malawi, we're considering the television band, like the UHF band.
And how did you first become aware of them?
Well, the idea of the white spaces firmly came to my attention last year around August. So, but the idea of having idle channels or dormant channels which are at the level of the white Gaussian noise in any radio system has been there in TV, for example, the band gaps.
Okay. And why is this important for Malawi?
In Malawi, we've seen that connectivity does contribute to development, and best connectivity in Malawi has been showcased with radio or wireless technologies, and we see that the white spaces is a radio-based technology, and with this, it has the potential robustness to propagate even through very remotest of the places, disconnected places. So we think that most of the population of Malawi could be connected through the television white spaces technology.
Now, other countries in Africa haven't rushed in to adopt white spaces technology. Why do you think that is?
Yes, I'm looking at the verb rush. Could it be a rush or not? But I think that maybe they have delayed. For us, I think we are actually in time to this. We have studied the white spaces technology for 1 year, research-based. Look at the other technologies. We have published a couple of papers in international conferences, and we think that it is very timely that the regulator has given an approval, is a partner, and that the International Center for Theoretical Physics, our collaborator, is also there. The funders have come forth with, like the OSF fund, to be able to finance this project. I think it is very timely that we move forward concretely and with tangible outputs.
And obviously the regulator is a key player in this in terms of managing spectrum. Do you have the support of the Malawian regulator?
Exactly. The regulator is key, and from the onset we did discuss with the spectrum department of our regulator, MACRA, and they were able to understand the concept very clearly. We coined several approaches to how to realize this one with the regulator, and because we have full support and the regulator has written an authentic letter of approval to use the white spaces that we so much identify using our spectral sensing technique in Malawi, we have been able to move forward confidently, which is not the situation in many countries which seem to have delayed or not rushed. The regulator is key to partner with.
Now, I understand you've chosen to take a slightly different approach to the implementation of white spaces.
Yeah.
In the US and the UK, the regulators there have chosen to go with a geolocation database that has to authenticate every radio that goes on, that turns on.
Yeah.
But you've chosen to go with the original definition of TV white spaces technology, where using a spectrum sensing technique. Is that true? And if so, why have you chosen that approach?
Very good, Steve. Guarding the old tradition is a wonderful thing. We wanted to guard the old tradition, but not just for no reason. The geolocation database does ask two important questions. The GPS location, where are you, for the white space device, and also what is the channel that could be available. And to compute the optimal solution, it bases basically on simulations, the simulated information on received power at a given place or location. We think this is only an estimate, and they would like to be very precise about the actual powers at a given free channels or not busy channels at a given spot. So our white space devices are cognitive radios, software defined, which have the capacity to sense and tell with a GPS stamping, time stamping, and reporting of a channel. Even if it's busy, they can still report on the same channel using bootstrapping to the base station, and then be advised to move to another adapted. So I think this is a very intelligent solution that we could do. It's complicated, but we have to work it out.
And can you tell us a little bit about the pilot that you're undertaking now, and who are the beneficiaries?
Yes, we're very excited. Today, we're launching 13th September. We're launching the pilot after an extensive study in Malawi, and the beneficiaries are basically sectors of socio-economic development in Malawi. The education sector, we have a Sunday school which will be connected to St. Mary's Sunday School. And then we also have the Air Force Department, which is in the remotest places. Most of their sectors are not connected. They would like to see if this could be useful for their security intercom, tactical issues. And then also the health sector. We have two hospitals, the Chancellor College Clinic, but also Pirimiti, which is a missionary hospital, the Roman Catholic based hospital, which is 20 kilometers away from here. This also is going to benefit by running medical applications on the infrastructure itself. And also the seismology department of the geological survey. Malawi has experienced 2-3 years ago tremors and earthquakes. We have craters and faults in most of the region here because of the Rift Valley. So, we'll be able to get to connect these places and have do monitoring, like disaster mitigation or early warning signs for this. I think Malawi will actually benefit a lot from this pilot, and then when we extend it nationwide.
That's really exciting. I'm looking forward to seeing the results of the pilot.
Exactly.
Do you have any words of advice you'd offer to other researchers on the continent or even regulators on the continent?
Yes, I think I would like to first talk to the researchers. I think the concept of dynamic spectrum allocation is a wonderful concept to optimize the usage or inefficiencies which are in there in the static spectrum allocation, which is a default approach by most of the regulators in the world. In the US, there was an announcement of first was a credit crunch, but which was obvious, but later on was a spectrum crunch. And I think few countries, if they do not move to dynamic spectrum allocation, I think this can also become a situation. So researchers must collaborate and negotiate and talk with the regulators, research together and make wide space a solution for dynamic spectrum, management or allocation, which is very key. I think with adaptive and cognitive radios, it should be very useful. So universities, industry, the regulators, governments should work together. This is my advice to them, and we can move together. Faster is better.
Dr. Mikeka, thanks so much for your time.
Thank you. My pleasure.